Hello, everyone. Today we'll be presenting the results of our research project. We'll start with our research abstract and proposal, then walk through how we cleaned and prepared the data set. After that, we'll analyze two of our models, and finally, we'll wrap up with the conclusion of our research. This project uses the Chicago Food Inspections data set, which contains records of health inspections in Chicago from July 1st, 2010 to March 18th, 2019. These inspections were conducted by the Chicago Department of Health and reviewed by licensed health professionals. Food inspections play an important role in ensuring that establishments follow safety regulations, identifying risk factors, and helping prevent foodborne illness outbreaks. The data set can be used to uncover patterns in restaurant performance and common violation. Our analysis focuses on identifying the key factors that influence whether an establishment passes or fails an inspection. To do this, we clean and explore the data, then apply two main models, classification and regression tree, and support vector machine. We also narrow down the dataset by removing variables that don't add predictive values such as ID number and business names. Our dataset contains over 183,000 inspections with a mix of categorical and numeric variables. The main questions guiding our analysis are: how important is risk in predicting whether an inspection will pass or fail? And does having more violations make an establishment more likely to fail an inspection? Ultimately, our goal is to determine which factors most strongly impact inspection results. These insights can help health inspectors prioritize efforts, assist owners in improving practices, and allow consumers to make more informed dining decisions.
All right, next we have the data dictionary. So we had 17 variables from the original data set and we added in 6 at the bottom. In total, we had about 1,300 missing variables, but when you compare that to the approximately 180,000 variables we have, it's not very significant. So we have a good mix of numeric and categorical, and we have the column and then the column number, the name of the variable type, the values that it has, which includes for numeric, the range, and then for categorical, a description or the options. And then we have the amount of missing variables, and then what does the variable mean. All right, so moving on to the data exploration, at the top we have links to the CSV file of the clean data, the original source, and the QMD file of our cleaning. And here we have the rendered file. So we start by looking at all of the data and the variables we have. And then we go on to clean the data, which first we rename the license number from license dot dot to license number, so it's more descriptive. We change the data types of inspection date, license number, and zip. We handle missing values in AKA name, facility type, and violations. And then we add new columns with violation information to help us go more in depth on the violations. So we have has violations, which is either a no or a yes. And then violations count, which counts the amount of violations. So that's a numeric variable. And then we add new columns for year and month. And then we make everything case specific and trim the text so that it all matches. And then we make risk numeric so that it's easier to analyze. And then we look at the city variable and see where we can clean. And you can see here we have a lot of like misspellings of like Chicago and just things to clean. So here we clean this and then we look at it again and it's a lot more, there's no misspellings or anything. And then we work on facility type and make a few changes to that. And then we make a new variable called result to generalized, which makes business not located, no entry, not ready, and out of business other, which we can see here. That's these four. And then it changes to this, which is a lot easier to read and more helpful. So then we look and explore some variables and make some graphs. So here we have risk number versus has violations, and we can see that risk level 1 has a lot more violations and it goes down in risk and violations. And then we can look here at violation count just as a histogram, and we can see that most have 0, but some have like 2 or 3, and then it goes down from there. And then we look at risk number versus results generalized, and we can see that one risk has mostly passes with a few of the others, and the others are the same, except 3 is pretty even on pass, fail, other, but not pass with conditions. But this could be hard to read because there's a lot more risk ones, so this could be skewing the data. So if we look at it in a fill way, we can see that it actually is pretty similar, except for risk 3 has a lot more others than the others, which can shift it. But we can see that 2 and 3 is pretty equal, but when we look up here, it doesn't seem that way, but it's just because there's a lot more risk ones. And then down here we have longitude and latitude, which shows us a map of Chicago and where all these places are. And then we have a box plot of risk number versus violation counts, and we can see that they're all pretty similar. There's not really a huge discrepancy in this. And then we have, here we go, year versus results generalized, and we can see that for the most part, it's pretty typical. There was a less others in 2010 and 2011, but then in 2018 and 2019, there's a lot of pass with conditions and less passes, which is interesting. And then we just look at the column names, and then we write a new CSV file of the clean data. And then down here, we have the data exploration summary, which goes into depth on the tidying and looks at these two graphs and the results generalized in year.
Okay, so this is our cart model for the food inspections data set. And here I loaded the data set in, and then we picked which variables we thought would be important. And we used zip, inspection type, longitude and latitude, if it has violations, the count, and the year that data was taken, month, risk number, and our results generalized is what we're using for our dependent variable. And then we are using only 5% of the data set due to support vector machines only being able to use 10,000 observations. And then here I had to filter the inspection type to not using ones that had less than 1 due to running issues with the cart model. And then here I created the training and data and testing sites. And then to make sure everything was working well, I looked for the NA values, and we found NA values in zip, longitude, and latitude. And we decided to remove them due to not being able to properly amputate them. And then here I made the first cart model using all of our variables. And down here you can see it had about 71% accuracy. And our most important variables were violation count, inspection type, house violation, and year. And you can see a steep decline between year and months. And then I made the next one that I decided to use less variables since a lot of them weren't very important. And it had the same model with the same accuracy, but it's important that we use the less variables because they were not necessary. And then I noticed that if you look at this model, that it uses has violations if it does or doesn't, which is about the same as if it does or doesn't, if the violation count is 0 or greater than 0. So in the last model, you can see that I decided not to use it as it didn't make a difference in the model. As you can see here, it just uses violation count less than 1 or not, and it still had the same accuracy, as you can see right here.
Okay, so now moving into the support vector machine. So for this model, we did the same thing as we did in the cart model where we selected these most important variables that were most likely to affect the results. And then we also selected 5% of the data in order for the data to be small enough that the support vector machine could handle it. And then we did the testing and training sets again using 65% and 35%. And we did use the same seed for both the CART model and support vector machine, just so we're comparing the same data. Okay, and then we created the model and we used all the different types of kernels that we learned. The sigmoid kernel had a very low accuracy of 55%. The linear kernel had a bit higher accuracy of 72%. Polynomial had 72% as well. And then the radial had a little bit lower, 71%, but all three of those last ones were very similar. But in the end, we decided that we were going to choose the polynomial kernel as our best one because it did have the highest accuracy and it had the lowest number of support vectors of the kernels used, the last three kernels. So that's why we chose that. And then from that model, we looked at the importance of the variables used to train it. And it gave us this graph. This shows how important each variable was in the model. And as we can see, inspection type, violation count, has violations, and year are all very important, which is kind of consistent with what we saw from the CART model. And then additionally, risk number was actually our least important variable. So this is all the variables. So risk number is very not needed in this model, which is interesting when we think about our research questions. Okay, and then moving on to our conclusion. So altogether, we made those two models to determine the answers to those two research questions. How important is risk in predicting whether an inspection will pass or fail? And does having more violations make an establishment more likely to fail an inspection? So the CART model had important variables, violation count and inspection type. Those are very important models or very important variables in its splits. And additionally, risk number was never used for the splits in that model. And then the support vector machine, as we just talked about, used inspection type, violation count, and has violations, with the least important feature being risk number. So with violation count appearing as important variables in both of those models, we can kind of conclude that yes, violation count is very important in predicting whether an establishment will pass or fail, and having more violations tends to lead to an establishment failing. And then finally, since risk number didn't appear in the CART models and was the least important in the support vector machine model, it tells us that it doesn't really have a lot of weight in predicting whether an establishment will pass or fail. And then one important thing we did notice was that inspection type was an important split in the CART models, and it was one of the most important variables in the support vector machine. And that kind of is interesting because we did not originally consider that variable. And then when researching that a little bit further, we found that all establishments are subject to annual inspections, and those inspections can be expected or unexpected by the owner of the establishment. And then inspections can also be done in response to complaints filed by customers. So that could be a reason why certain inspection types are more likely to result in a fail or pass. But doing more research on that could give us more interesting information. And so in the future, individuals can use our results in order to quickly estimate if an establishment is going to pass or fail based on its number of violations, and they can also look at the inspection type. And then we also determined that they should just generally ignore the risk number as it doesn't really have a lot of predictive power. So this can be used by analysts, people in the food industry, customers, and food inspectors just to quickly find out if a business is going to fail an inspection. Thank you.